All. In the last video, we spoke about perfect binary tree and then we spoke about complete binary tree and we discussed what is a heap data structure, how it is represented in the form of an array and different types of heaps. To recap, basically a heap is a complete binary tree, and one more property of the heap is, since there are two types of heaps such as maximum heap and the minimum heap, for a maximum heap each node is greater than its child nodes, and for minimum heap each node value is lesser than its child nodes. So those are the two properties of a heap. So in this video we will talk about insertion of an element in a heap. Now there are basically two operations that can be performed on a heap. One is insertion of an element in a heap and the other one is how to delete an element from the heap. First we'll talk about insertion and then we'll move to deletion of an element in a heap. So this is a maximum heap as we discussed in the last video. Now let's say I want to add element with 20, uh, element with 20 to this heap. Okay, so what should I do? Basically, if you don't know the steps of insertion of an element in a heap, what people usually do, as soon as they see this element 20, uh, everyone thinks that okay, 20 is greater than 10. I'll update 20 here directly on the root node because I'm using a maximum heap, and for maximum heap the value should be lesser than its children, right? So what people think is they'll put 20 here as soon as they see 20. Now you will have 10 here, right? Now what happens is they'll compare 10 with 9 and 8. Okay, 10 is greater than 9 and 8, and among these three elements 8 is the smallest one. So we will think we'll update 10 here and we'll take out 8. Now 8 will be compared with its children 2 and 1. Okay, 8 is greater than 2 and 1, and among these three elements 1 is the smaller one, and we will try to keep 8 here. When we put 8 here, automatically 1 will be moved down, right, as its right child. Okay, now if I do this, okay, when I do this, this is the right child. I'll move a little down here. Yeah, okay, right child. Is this a heap? What are the two properties of the heap? One is it should be a complete binary tree, and the other one is it should follow this greater than property. Now this is not a complete binary tree, because for a complete binary tree at the last level elements should be arranged from left to right, but here it is arranged at the extreme right. So it is not following the heap property. So whatever we have done is wrong because it's violating heap property. Okay, so you shouldn't do like this. Now let's talk about the procedure, how you should do an insertion. I'll undo these changes whatever we have done here, and let's start. Okay, now 20. So what we should do is, whatever the element we take, be it is greater than node or lesser than node, what you should do is you should insert these element at the end of the heap. At the end, when I say, what it means is, at the it should be placed to the last. So let's say I already have 20, now I want to insert 30. It should be placed next to it. So it should be placed at the end. Now it is following the complete binary tree, but it is not following this maximum principle, because 5 5 ideally it should be greater than its children, but it is lesser than the its left child. So it is not following the heap property. Since the complete binary tree property is followed, we will adjust the second condition also. Since when we compare 20 and 5, 5 is lesser than 20, right? So what we'll do is we will swap both. Okay, I'll swap 20 and 5. When I swap this, okay, 20 is greater than 5. So for this node, the greater than condition is followed. Now since I have modified this, we have to compare it with this parent. Now when I compare 20 with its parent, 9 is lesser than its child, so it is violating it. So I should swap here also. I'll move 20 here and I'll move 9 here. Okay. Now, I have modified this value. When I modify this value, there might be a case that the parent and its child might not follow the heap property. So I'll compare it with its parent. When I compare 20 and 10, 20 is greater than 10, which should not be ideally. So I'll swap this 20, 10. Now I have reached the root node of the tree, and there's no possibility of swapping more. Now let's check the condition. Anyway, it is a complete binary tree, and 20 is greater than 10 and 8. 10 is greater than 9 and 6. 8 is greater than 2 and 1. 9 is greater than 5. So it is following the heap property. It's a complete binary tree and each node is greater than its children. Okay. So this is the ideal process of inserting an element in a heap. Now let's calculate the time complexity of this. Okay. How many swaps you have done? 1, 2, 3. At most you have done 3 swaps. There can be no swaps also. How that is possible? Now let's say I want to add an element of value 4 here. Okay. Like I'll add 4 here. When I added 4, it's already following the heap property, right? When I added 4, it's already following the heap property because 9 is greater than 4. I need not do any swaps here. So the best time complexity is order of 1, in which you don't do any swaps here. And the worst time complexity is it is equal to the height of the tree, because let's say I insert a node which is greater than root node. How many swaps you have to do? You have to do number of swaps equal to the height of the tree, because here you are going up, you are moving up, so it means that you are going one by one level, so it's equal to the height of the tree. So the time complexity, of for to insert an element in a heap is log n. It's a anyway it's a worst time complexity, but in the best case you can have order of 1. Best time complexity is order of 1. Okay. Yeah. So this is the time complexity of insertion of an element in a heap. Now you will write the procedure also how you will do. One is you insert the element at the end. Insert the element at the end of the heap. And the second one is compare the element with its parent, and then sum the values recursively till we reach the root node of the tree. Okay. This is the condition. Now let's try inserting one more element. Okay. I want to insert 7 here. What I'll do is I'll insert 7 because I'm inserting at the end. I'm not checking anything. I'm just inserting on the end. After that, I'm doing the adjustments. I'm inserting in at the bottom and I'm pushing the element to the top. So here from bottom to top, you are doing the operation. Now let's say I'll insert 7 here. Okay. Now this becomes the left child of the 6. Here 7, when I compare 7 with its parent is lesser than 7, which shouldn't be possible ideally. So I'll swap 7 with 6. Now I'll compare 7 with its parent 10. 10 is greater than 7. So I should end here. I should end this process here. Okay. So this is how you insert an element in the heap. In the next video, we'll talk about deletion of an element in the heap. Thank you.